Welcome. Today, we're diving into something that's absolutely fundamental for anyone who builds electronics. We're going to tackle how you take that crazy powerful electricity from a wall outlet and turn it into the clean, stable 5-volt DC that your projects actually need to survive. So let's break down this journey.
You plug your phone charger or your latest project into the wall and it just works. But have you ever really stopped to think about what's going on inside that little black box? How does that raw, high-voltage power not just instantly fry all those delicate little computer chips?
Well, the secret is understanding that we're dealing with two totally different kinds of power. From your wall, you get this high-voltage alternating current. Honestly, you can think of it as wild energy. It's super powerful, but it's chaotic. Your electronics, on the other hand, they need something completely different. Low-voltage, direct current. This is like a tame, steady little stream of power they can use safely. So the entire challenge is figuring out how to tame that wild energy.
All right, so our journey starts with the biggest, scariest problem first, that massive voltage. This is step one, and it's probably the most critical part of the whole process.
The first tool we're going to use is the step-down transformer. You can think of it like a gear shifter for electricity. It takes that super high input voltage from the wall, and through the magic of magnetic fields, it safely converts it into a much, much lower output voltage.
So, to put some numbers on it, our circuit grabs that dangerous 230 volts of AC from the wall, and boom, the transformer drops it all the way down to a much safer, much more manageable 12 volts. Okay, so we've solved the voltage problem, but it's still AC, and that's our next big hurdle.
Okay, so the voltage is safe now, which is great, but we have another problem. See, it's alternating current, which means the electricity is literally flowing back and forth, back and forth. Our electronics need direct current. That's a one-way street. So how do we fix that?
To solve this little puzzle, we bring in a component called a diode. And the idea here is just brilliantly simple. A diode is literally a one-way street for electricity. It lets the current flow forward, no problem, but it completely slams the door shut if it tries to go backward. This tiny component is the key to our next transformation.
So when you actually look at a diode in the real world, like the 1N4007 we're using here, you're going to see a really important detail. A little silver strip on one end. Now that band always marks the cathode, which is the negative side. You have to get this orientation right. It's absolutely essential for the circuit to work.
Now, one diode is good, but 4 of them working together as a team is where the magic really happens. When you arrange 4 diodes in this special way, it's called a bridge rectifier, and it does something so clever. It basically grabs the negative part of that back and forth AC wave and just flips it upright. And the result? We've officially turned our alternating current into a kind of bumpy, pulsating version of direct current. We're getting so much closer.
Okay, so we have DC, which is awesome, but it's pulsing up and down like a heartbeat. If you tried to power a sensitive chip with this, it just wouldn't work right. We've got to smooth out all these bumps and turn it into a nice, steady, flat line. And to do that, we need our next component, the capacitor. A capacitor is basically like a tiny, super fast charging water tower for electricity. It charges up on the peaks of those DC pulses, and then it releases that stored energy to fill in all the valleys. The end result is a much, much smoother flow of power.
Now, just like with diodes, some capacitors have a right way and a very, very wrong way to be installed. With these barrel-shaped electrolytic capacitors, polarity is absolutely critical. You can spot the negative side by looking for the big stripe of minus signs running down the body. And usually the positive leg is a little bit longer. You got to get this right, because if you install it backward, you can literally destroy it.
For this circuit specifically, we're using a 470 microfarad electrolytic capacitor to do all the heavy lifting. It's our main filter, taking that bumpy DC from our rectifier and smoothing it out into a much more stable, usable voltage.
We are so close now, you can almost taste it. Our power is a pretty smooth DC current, but it's still not a perfect 5 volts. For that, we need one last component to act as our final super strict gatekeeper.
And that gatekeeper is the voltage regulator, specifically the legendary 7805 integrated circuit. This amazing little chip has one job, and it does it perfectly. It takes whatever voltage you give it, as long as it's a little higher than its target, and it outputs a rock-solid constant voltage. And the 05 in its name tells you exactly what that is, 5 volts.
And using this chip could not be easier. Pin 1 is your input. That's where our filtered DC comes in. Pin 2 is your common ground. And pin 3, that's the magic pin, the output. That's where we get our stable, positive 5 volts.
Just remember, input, ground, output. It's that simple. Now, the regulator doesn't work totally alone. Our circuit also uses a couple of small ceramic capacitors. They aren't there for the big filtering job. They're just there to help the regulator deal with any tiny high-frequency jitters and make sure its operation is perfectly stable. You can think of them as the regulator's little helpers.
All right, that's it. The circuit is complete. We've gone from the wall outlet, through the transformer, the rectifier, the filter, and finally our regulator. The moment of truth has finally arrived.
So, after all that work, after taming, flipping, and smoothing this electricity, what does the multimeter actually say we have? And there it is, 4.93 volts. That is fantastic. I mean, in the real world of electronics, that is a perfect, stable, and totally usable 5-volt supply, ready to power pretty much anything we want. Success. So let's just do a super quick recap of this incredible journey our electricity took. First, we transformed the high voltage down to a safe level. Then we rectified the AC into bumpy DC. After that, we filtered that bumpy DC into a smooth DC, and finally, we regulated that smooth DC to get our stable, perfect plus 5 volts.
And believe it or not, this 4-step process, transform, rectify, filter, and regulate, is the foundation of almost every single electronic device you own. So now you know the secret. You know how to safely take power from the wall and use it to bring your own ideas to life. The only question left is, what are you going to build?